Hello everybody, welcome to Advanced Operating System. I am Sweet Innocent Chair standing for Dr. Lienou Pierre. Advanced Operating System. In this course we are going to look a general overview of operating system, types of operating system, services, properties of operating system, processes, process scheduling, scheduling algorithms, multi-threading, memory management, virtual memory, input output hardware, input software, file system, security, Linux operating system, which we'll do as our practicals. Overview. Generally, an operating system is an interface between the computer user and the computer hardware. The operating system is a software that performs all basic functions and it performs several basic functions, and some of the functions of the operating systems are file management, memory management, process management, handling input and output. Examples of operating systems: we have the Linux operating system, Windows operating system, quite popular, VMS OS 400, AIX ZOS, and so on. Definition: an operating system is a program that acts as an interface between the user and the computer hardware. It equally controls the execution of all kinds of programs. Now take a look at this diagram. The operating system, this is the operating system falls in the middle section, interfacing the users and the hardware. Now in the middle section, it contains the software, which is further divided into two sections. We have the system software and the application software. Now application softwares are a software that help in the installation or help in providing the user with a particular function, right? They solve user particular problem, while system software help in interfacing the operating system with the hardware. The operating system is a type of system software. Other system softwares include utility programs, drivers, and so on. So the operating system, the operating system serves as an interface between the users and the hardware. Now we know that memory management, process management, device management, file management, security, control over system, job accounting, error detecting, aid, coordination between other software are functions of the operating system, right? These are functions of the operating system. So now let's look at each of these functions. Memory management. Now, memory management refers to the management of the primary memory or main memory, often called the RAM, right? The random access memory. Now managing this memory, the main memory provides a fast storage and can be directly accessed by the CPU through buses. Now we'll look at this. There are several types. We're going to look at buses later, but before we go ahead, just so you know, there are several types of buses. We have the instruction bus, status bus, and data bus. Now instruction bus carries instructions, status bus carries the status of the memory, data bus carries data. It's like a channel that links the main memory to the central processing unit. For a program to be executed, it must be in the main memory, and the operating system is going to decide what quantity of the main memory that process takes, and it equally is equally going to allocate that memory to the processor, and the process and the operating system will be responsible for deallocating the memory when the processor no longer needs it. The operating system equally keeps tracks of the memory and how it is being used, and who uses it at a particular time. Processor management. Now, in a multi-programming environment, the operating system decides which process gets to use the processor and for how much time. This function is called process scheduling. We shall look at it detailedly and the various algorithms of process scheduling shortly. An operating system does the following activities for process management. It keeps tracks of the processor and the status of the process. Now, the program responsible for this task is known as traffic controller. The program responsible for keeping track of the processor and status of the process is called a traffic controller. The operating system equally allocates the CPU to a process and deallocates the CPU when the process no longer requires it. Device management. The operating system controls devices through their respective drivers, and it does this by keeping track of all the devices. The program responsible for this task is the input-output controller. The program responsible for keeping track of all the devices is the input-output controller. Devices which process get the device, when and for how long. So it decides when a process is going to get a device and what time and for how long. It equally allocates devices in an efficient way and deallocates devices. File management. A file system normally is organized into directory for easy navigation and usage. This directory may contain files and other subdirectories. Now, an operating system does the following activities for file management. First, it keeps track of information, location, uses, and status. The collection facilities are often known as file system, right? Now, the operating system equally decides who gets the resource. It allocates the resource and equally deallocates resources. Other functions of the operating system include security, that is providing a password before access, control over the system. It records delays and performance. It records delays between requests for a service and response of that service. Job account. It keeps track of the time and resources by various jobs and users. Error detecting aid. The operating system has aids which can help in the detection of errors, and when it detects such errors, it can lead to the production of DOMs, traces, error messages, or debugging. Now, these DOMs could be deleted from the computer. Coordination between other software and users. The operating system coordinates the system itself with other software and other users by providing compilers, interpreters, assembly, and libraries to other application programs using the operating system. There's types of operating system. There are several types of operating system, but we'll discuss just the important ones. In the early days when operating system was just discovered, we were using what we call a batch operating system. In this type of operating system, jobs were being prepared by each user. Each user is going to prepare a job, and then is going to send that job to the operator. The operator is going to classify the jobs into similar jobs so as to speed up processing. And once the operator has classified the jobs into similar jobs, He can then put the jobs into the computer for processing, and then when the output comes out, the users will come collect the output, and that is how the batch processing works. Now the batch processing has some problems, like there is a lack of interaction between the user and the job. The CPU is often idle because the speed of the mechanical input output device is slower than the CPU, and it is difficult to provide the desired priority. Time sharing operating system. Now this technique enables many people located at various terminals to use a particular computer system at the same time. Time sharing or multitasking is a logical extension of programming processors time, which is shared among the multiple users simultaneously. Simultaneously, it is also known as simultaneous, so it is known as time sharing. That's what actually happens, where several users can use the processor at the same time. It's known as time sharing. The main difference between multi-program batch system and time sharing systems is the case of is that the case of multi-program in that is the case that multi-program batch systems, the objective is to minimize processor use, while time sharing system, the objective is to minimize the response time. So just take note of that. Some of the advantages of time sharing system is that it provides quick response time, it avoids duplication of software, and it reduces the idling of CPU. The problem we have with time sharing operators is that there is little reliability. Again, the question of security and integrity of the user, program, and data is not something of certainty. We also have problem with data communication. Next type of operating system we shall be looking at is the distributed operating system. This type of operating system is very recent, and it works in such a way that it uses multiple central processors to serve multiple real-time applications and multiple users. Now, data processing jobs are usually distributed to the processors accordingly. These processors communicate with one another. Through communication lines, and these communication lines are what speed buses or telephone lines, but mostly is using what speed buses. We have just seen the various type of buses above: instruction bus, status bus, and address bus. Now they are sometimes referred to as loosely coupled system or distributed system. Processors in these distributed systems may vary in size and function, right? And so these processors are referred to as sites, note, or computers. The advantages of distributed systems is that it promotes resource sharing. Several computers could just use maybe a single printer. It speeds up the exchange of data through electronic mail. If one site fails in the distributed system, the remaining sites can continue operating. So it reduces the risk of failure. Now it provides a better service to customers. There's great reduction in load of the host computer, and there's equally reduction of delay in data processing. That is the data processing is done faster, and it takes lesser time. Network operating system. This is a type of operating system that runs on a server, and it provides server capability to manage data, user groups, security, application, and other networking functions. The primary purpose of network operating system is to allow shared files and printer access among multiple computers. They usually function in a network. They could function maybe in a LAN, in a private network, or other networks that you know. Examples of server operating system: we have Windows Server 2008, Unix, BSD, NetWare, and so on. The advantages of network operating system involves centralized servers, which they are usually highly stable. Security is server managed, meaning that if your server is well secured, the rest of the hosts are equally secured. Upgrades to the new technology can easily be done because it will just be done on the server, and the host computers will just benefit directly from such an update. We have as disadvantage the high cost of buying and running such servers. It is equally just dependent on the central location for most operation. The regular maintenance and updates is equally required most of the time. Real-time operating systems. This type of operating system are the type that it takes very little time to process a request and give a response in such a way that it is almost instantaneous. Now, the time taken by the system to respond to an input and display the required updated information is termed as the response time. So it means that the response time is extremely small as compared to online processing. Real-time systems are used when there are rigid time requirements on the operation of the processor or the flow of data, and real-time system can be used to control device in a dedicated application. For example, we could use real-time systems in medical imaging systems, industrial control systems, weapon systems, robots, air traffic control systems, and so on. There are two main types of real-time operating system. We have the hard real-time system and the soft real-time system. The hard real-time system guarantees that critical tasks are completed on time, and the hard real-time system it is limited or missing. Right, the storage is limited or missing, and data is stored directly into the ROM. This system, virtual memory, is hardly used there. Soft real-time system is less restrictive. A critical real-time task gets priority over the other tasks and retains the priority until it completes. Now, for soft real-time system, they have limited utility than the hard real-time system. For example, we have multimeter, virtual reality, advanced scientific projects like undersea exploration and planetary rovers. Operating system services. Operating system services. These are services provided by the operating system. They include program execution, input-output operation, file system manipulation, communication, error detection, resource allocation, and protection. Now, I'm not going to explain this, so you're going to read it. Program execution, input output operation, file system communication, error handling. You're equally going to read the operating system properties. They are quite easy to understand, so it's not a big problem. Now, I'm going to start explaining from here. Operating system processes. A process is basically a program in execution, and the execution of a process must progress in a sequential fashion. Now, a process is defined as an entity which represents the basic unit of work to be implemented in the system. Now, to put it in simpler terms, we can say that a computer program in a text file, when we execute this program, it becomes a process, right? Now, what happens when we load a program into the memory? It becomes a process, and it is divided into 4 sections: stack, heap, text, and data. Now, the following image will show these 4 sections of a process in a simplified form: stack, heap, and data. Now, what is a stack? The stack will contain temporal data such as method function parameters, and local variables. The heap, on the other hand, is a dynamically allocated memory to the process during its runtime. Now, data will contain global and static variables. Text includes the current activity represented by the program counter and the content of the processor's register. That is what is in text. A program is a piece of code which can be a single line or it could be millions of lines, and these lines are instructions that are executed by the computer. For example, this is a simple program in C. Hash include stdio.h, that is a library. Int main, a function. Printf hello world, that is an instruction. Return 0 is an instruction, right? So this is an instruction. What happens is that when you take this piece of code, it is now text. You put it in, you run it. It's going to execute and display this on the screen. Hello world. Process life cycle. Now, when a process executes, it passes through different states. The stages may differ in different operating systems, but the names of these stages states are not standardized. In general, a process can have 4 to 5 states. Now, we have shortlisted 5 states here. We have start, ready, running, waiting, terminated or exit, all summarized in this diagram below. Now, at the start process, what happens? This is the initial state when the process is first created. So at this level, the process is first created. Once the process is created, it moves to the ready state. At the ready state, it is waiting to receive the processor in order to execute, right? Now, once a processor is assigned to the process, it moves to the running state. At the running state, the process could be interrupted. If the process could be interrupted and the processor given to another process. So if that process is interrupted, it could move back to the ready state. And once the processor is reassigned to that process, it comes to the running state. Now, while at the running state, it could happen that it's waiting for a file, or it's waiting for the user to put in for the user to send an input, maybe through the keyboard or through the mouse. Is going to move to the wait state. Now, once it has received maybe the file it was waiting for or the input from the user, it moves to the ready state. And if when the processor is reassigned to that process, it comes to the running state. Now, when the process has finished running, that is executing, it shall be terminated and it goes to the termination state. Process control block. It is a data structure which the operating system maintains for each process, and it is identified by a unique number called the process ID or PID. You could always type you could press press Windows plus R to have the run bar, and you type task mgr to get the task manager, and then you click on more details, right? Let's just do it. You press Windows R and you type task manager. Yeah, you have what? The PID. You see, it shows it's a unique number for each of the process that is running inside the computer, right? Now, what is the information that is kept inside the PCB? We have the processor state, processor privileges. The processor state will give us whether it will tell us whether that process is running, is waiting, or the other ones. Process privileges. It is required to allow or disallow access to system resources. The process ID is the unique number that will identify a particular process in the operating system. The pointer will point to the parent process. Program counter is a register that contains a pointer to the next address of the instruction, or that contains the address of the next instruction to be executed by the processor. CPU registers are fast memories that store the execution of for a running state. CPU scheduling information is the process priority or other scheduling information which is required to schedule the process. Memory management information, it includes information of the page table, memory limit, segment table depending on the memory used by the operating system. Accounting information, it includes information about this process execution time, limit, execution ID, and so on. Input output status information, it includes the input output devices allocated to the process. Now it could be represented as a diagram as shown below. Process scheduling. Two-state process model. The two-state process model refers to running and the non-running state. The running state is when a new process is created and it enters into the system as a running state. The non-running state is when processes are not running. Then those processes which are not running are kept in the queue, and each of these processes that is kept in the queue will wait for its turn to execute. Now these processes that are kept in the queue, they point to a particular, that is that they are pointers to a particular process, and this queue is implemented using linked list rather. Is implemented using linked list. Schedulers. Schedulers are a special a special system software that handle process scheduling in different ways. Now, there are three main types of schedulers. We have the long-term schedulers, short-term schedulers, and medium-term schedulers. First, you have to know that a scheduler's main task is to select job and choose the job which is going to execute at a particular time. Now, long-term schedulers. It is also called a job scheduler. Its function is that it selects from a pool of jobs. It selects from a pool of jobs and it selects particular jobs from a pool of jobs and sends them in for and puts them in a queue so that they can be processed. Short-term schedulers. Short-term schedulers selects from the queue of projects which long-term schedulers have put. That is the projects that are ready. Short-term schedulers selects from those projects and sends them into the main memory for execution. Medium-term schedulers. Medium-term schedulers are responsible for swapping. These are the schedulers that if let's take for example that a process is running, these schedulers and that process requires maybe an input output and it makes an input output request. That process cannot continue until that request is granted. Such a process will be swapped, will be sent out of the main memory and placed in the waiting zone, and then another process will replace it, and so that the processor will not be idle. That is the function of the medium-term schedulers. This table summarizes the comparison between long-term schedulers, short-term schedulers, and medium-term schedulers. Context switch. Context switch is a mechanism to store and restore states of a process in the CPU. Now what happens? Let's take for example that we look at this diagram. Let's say we have I hope everybody's seen. Let's say we have two processes running at the same time simultaneously. That's called multi-programming, right? Now, process 1 and process 2. Process 1 is running and the processor wants to switch to process 2. What happens is that it saves the state of process 1. What happens is that it saves the state of process 1 and then it goes to process 2, right? It saves the state of process 1 and then it comes to process 2, restores the state of process 2 and continues executing. Now, if it happens that it wants to return back to process 1, it saves the state of process 2 and returns to process 1 and continues executing. Operating system scheduling algorithm. Now, these are the different processes to assign a CPU-based particular scheduling algorithm. There are 6 scheduling algorithms. We have the first come, first serve, shortest job next, priority scheduling, shortest time remaining, round robin scheduling, multi-level queues. We shall do each of these algorithms and see how they function.